Back in 2017, a paper came out with a really simple title, but an idea so powerful it would completely change the direction of AI. Seriously, it didn't just suggest an improvement, it basically tore up the old rulebook and started over. And in doing so, it built the very foundation for the AI that we all use every single day.
All right, let's get into it. First, we're going to talk about the massive problem AI was facing, this sequential bottleneck that was holding everything back. Then we'll get to the wild new idea they proposed to fix it. We'll peek inside the transformer, uncover its secret weapon, self-attention, see how it just destroyed the old records, and finally wrap up with how it kicked off this whole new era of AI.
So before this paper, the world of language AI was pretty much dominated by one kind of model. But these models had a huge fundamental flaw, a built-in speed limit they just couldn't break.
Think about how you read a sentence. You go one word at a time, right? In order. Well, that's exactly how the old models, like recurrent neural networks or RNNs, worked. And it seems logical, but it created this giant problem. Since the model had to process the first word before it could get to the second, and the second before the third, and so on, it was impossible to look at the whole sentence at once. The paper calls this the inherently sequential nature, and it meant you couldn't parallelize the work. You couldn't do a bunch of things at the same time. This made training these models on long pieces of text just painfully slow.
This chart from the paper just lays out the problem perfectly. On the left, you've got the old way. Think of it like a bucket brigade. For water to get to the 10th person, it has to pass through the first 9. The longer the line, the longer it takes. That's the problem. But the transformers approach, over on the right, it's like everyone in the line can see the well at the exact same moment. It doesn't matter how long the sentence is. The information between any two words can travel instantly. This wasn't just a tiny improvement. It was a complete and total game changer. So the researchers behind this paper looked at that whole sequential mess and asked a really powerful question. What if we're focused on the wrong thing? What if you don't need to read word by word at all?
And that question led to their core idea, spelled out right there in the title of the paper. They suggested just getting rid of that slow, sequential process entirely, and instead building a new kind of model based only on a mechanism called attention. The idea was, instead of a word only knowing about its immediate neighbors, it could look across the entire sentence at once and pull in context from anywhere to figure out its true meaning.
So to make this idea a reality, they had to design a completely new architecture from scratch. And they called it the transformer. And here it is. This is the now famous diagram from the paper. It's the blueprint for the transformer. I know, it might look a little complicated, but it really just boils down to two main parts that work together, the encoder on the left and the decoder on the right. So the encoder's job is basically to read and understand. Think of it as the part of the model that takes in a sentence, let's say in English, and creates this rich mathematical representation of what it means, capturing all the subtle relationships between the words. Okay, so once the encoder has understood the sentence, the decoder takes that understanding and gets to work. Its job is to be the writer. It generates the output, for example, the German translation, one step at a time, using the context that the encoder provided.
But hold on. What lets these two parts work without that slow word-by-word process? Well, that brings us to the core innovation, the real secret sauce of this entire paper.
It's all about this idea called self-attention. To put it simply, for any word in a sentence, self-attention lets the model look at all the other words in that same sentence and decide which ones are the most important for understanding that specific word. It basically creates a direct connection between every single word, all at the same time.
So, how do they actually build this? Well, on the left here, you see the basic engine of attention. It takes in a word and helps it look at all the other words. But here's the really brilliant part, over on the right. Instead of just having it look once, they made it look multiple times, all at the same time, in parallel. They called this multi-head attention.
So why do this? Well, this whole multi-head thing is like having a team of 8 experts read the same sentence. One expert might focus just on the grammar, how verbs connect to nouns. Another might be looking at the overall meaning and tone. A third could be tracking who is doing what to whom. By having each of these heads focus on a different kind of relationship and then combining all of their insights, the model gets a way richer, more complete understanding of the text.
This was all a fantastic theory, a brand new architecture, powered by this multi-headed self-attention. But the real question was, did it actually work? Well, the answer came in the form of results that absolutely stunned the entire AI community.
On a key test for translation quality, something called a blue score,
the transformer hit 28.4. Now, that number by itself might not mean much to you, but in this world, improving that score by even a little fraction of a point is a huge deal. The transformer didn't just nudge it up, it improved it by over 2 full points. That's massive.
And it wasn't a fluke. On another big test, it set a new record of 41.8. But the really mind-blowing part wasn't just that it was better, it was how much more efficiently it got there. It was achieving these incredible results in a fraction of the training time at a fraction of the cost.
And here is the proof in black and white. The transformer, that bottom row, gets the best scores for quality. But now look at that last column, training cost. That's a measure of the raw computing power you need. The transformer needed way less power to get a better result. This was the holy grail. It was better, faster, and cheaper.
The transformer wasn't just some small, incremental improvement. It was a fundamental shift in thinking that set the stage for everything that was about to happen in AI.
So here's the real legacy of this paper. That one brilliant idea, swapping out slow, step-by-step processing for this parallel, all-at-once self-attention, was the key that unlocked the massive scaling that we see today. Every single major large language model you've heard of, from BERT to ChatGPT, is built on the foundation that was laid down by this transformer architecture.
By answering one of the biggest questions of its time, this paper basically defined an entire era of AI. And it leaves us with the next huge question, doesn't it? If attention was this era's breakthrough, what's going to be the next one?